So with this question, let's look at how units are important to find the values that, well, they're not so straightforward. Like in this case, density. We don't see so many equations with density in chemistry, yeah? But the first thing is room temperature and pressure, because we know that, and always, whenever we read the room temperature and pressure, this number with these units should pop in our mind, decimeters cube per mole, very important. Okay, I'm highlighting today the units and how they can help us finding an element. Okay, because remember that the definition of this is molar volume, so it's is that 1 mole of any element at room temperature and pressure occupies 24 decimeters cube. So to rephrase it, in this unit, 24 decimeters cube per mole are occupied. Yeah, so that's what really the unit tells us. Okay, if you think about the density, is the same. It's similar in sense that is the amount, the grams per centimeters cube. Yeah, as we know, the density is the amount of substance in a certain volume. Okay, translating these units into words. Okay, but what can we do? So if we observe these units, we have decimeters cube per mole, and then grams per centimeters cube. We need to think about, okay, what can we do with them? Well, we have 2 volumes unit, so that's something, because we know that we can convert one. In fact, we could either convert, actually it might be easier. We know the other form of this is that 24,000 centimeters cube per mole. Okay. Now, what could you do with those 2 units? Well, they can actually cancel each other out. But why would that be important? So the other approach, it would be thinking, okay, how do I find the element? What defines an element? Well, the thing that we know from the periodic table, not the number of protons, so not the atomic number, but the mass number, which is also the molar mass. And we know that the molar mass has a very important unit that we use to work out the equation for the moles and so on. It's grams per mole. So now that we have centimeters cube per mole and grams per centimeters cube, we have also grams per mole. We just need to think about how to bring them together. In fact, if we do, and I don't really care about the number, I'm just going to show you the unit. We have centimeters cube divided by moles. That's the same when we have the reciprocal. If we times it by grams per centimeters cube, which is the unit of this density, guess what we have? We end up with grams over mole, the unit of the MR. Okay, so I haven't plugged it in the calculator, but we can try it. It's relatively simple, the numbers. So we have we have these 24,000. We will time it by 1.33 times 10 to the minus 3. So 31.92 is the value. Let's round it to 32. What element would have this density? Well, we can think about an element of 32, or think that we're talking about a gas. Which gases are the most common? Oh, one exactly has a 32 as a mass, and that is oxygen, because that's also something to think about, is a diatomic molecule. Okay, anyway, that was a bit tricky to find that 32 was for true atoms of oxygens, that because they exist as elements. So, but that's the key thing also. If it's element, you know, that we consider their state, yeah, their elemental state, which for some of the elements is a diatomic molecule. Okay, but anyway, the takeaway point is look at the units, how we can bring them together to find the desired unit, which is in this case was the molar mass. Okay.